See what's on the screen.
Okay.
Yeah, and if when it's
Okay.
slides or not slides, it's not always the best. So having another
Okay.
angle wouldn't be the worst.
So I'm on the Wi-Fi. What's the Zoom?
718 to open up Zoom.
Yeah.
Yeah, exact. 718 634 0613.
Okay.
And then middle here.
Recording in progress.
Okay.
Yeah, it looks pretty good if we just record that.
And mute
I
your
got mute. Okay, cool.
Filing in the next 10-ish minutes. In that time, you want to do some pleasantries, tell us about what you do at City or Way Research, whatever you like.
Yeah, sure.
Take your time, take your time.
I'm just trying to get this to go full screen. View. Okay. Cool. I don't know if this is gonna turn off.
With that little pop-up guy.
Oh, yeah, we can close that.
Okay, yeah, that's great. Okay, yeah, so I work for Citibank most in my full-time capacity. I work on a credit derivatives trading desk. We trade things called credit default swaps. I don't know if any of you are familiar with the CDS. Essentially, like people, large businesses buy huge bond positions. And so like you could buy like $30 million of target company bonds, like which is a corporate bond. And say you're worried that Target might go through a default because of their policing practices and whatever you think about Target. So you would go to us and be like, hey, can I buy insurance on those bonds? And we'll sell you, it's like kind of like an option contract on the bonds that say if they default, we will pay you back the money that you invested in the target bonds. And if not, we'll just hold on to your premium. It's pretty much just an insurance contract. They're widely traded. I do the plumbing for those, so my job is super boring. I'm trying to get out of there. I like do a lot of the regulatory work and stuff that really is just boring. So yeah, and then in my spare time, I run an AI research and development company called Way Research. We build AI applications, machine learning models, pretty much most anything that has AI in it, we can build it. And that I've been getting off the ground for the past year and a half. I'm just signing up some of my first clients now. And we're always looking for people to help out. So if you like building AI things, if you like working on large scale machine learning projects, that's kind of what we do. But as far as like why I'm giving this talk, as it doesn't really pertain too much to the things I just discussed. I've been working in the finance and machine learning industry since like 2015. But yeah, I can get that more of the talk, kind of why my background has some relevant pieces to this. If you guys want to kick around, we can shoot the shit for another couple of minutes, or should we get going here? I mean, I don't want to start early.
Let's keep shooting the shit.
Okay.
What is your education background?
Yeah, so I got a BS in statistics from Loyola University of Chicago. I was supposed to graduate in 2016, but I actually left school a year early to start working in the industry. And I never received a diploma. I was just working, and I worked for a couple big name companies. And then in 2018, I moved back to Buffalo. And right after I got laid off from one of those jobs, and I realized that I couldn't get a real like job because I never got a college diploma. I had the work experience, so I went back to Loyola. I took classes at UB, took classes at Loyola, finished up in 2020, and then started working at City shortly after. So that's kind of been my progression. Yeah.
That's exciting.
Excellent.
Yeah, it was really exciting. It was good to go back to school. I took some intro to probably math stat classes, and cool. I hadn't done a lot of calculus in a long time, so it's really fun.
What's your relationship with, I guess, the tech side of things, besides obviously you're in AI, but how'd you get?
Yeah, so like I guess I started programming Python in 2012, 2011, in high school. And I just kind of started building things. I didn't really know what I was doing or even why I was doing it. I was just playing around with Python and building little programs to do stuff. Then I came to Loyola, and I was originally like a math person. I was originally a physics person, and I was like, oh, I want something more applied. So I switched to pure math, which just ended up being a lot of theory courses. So I know a lot about number theory. That doesn't necessarily help me on a day-to-day basis. And then I was like, wait, I need something I can actually use in like business and the real world. So I switched to stats. And in my second year in stats, I took this class called Intro to Non-Parametric Statistics. And one of my professors, who was a 4-time Kaggle champion of the machine learning March Madness Bracket Prediction Challenge, lumped in machine learning methods as a non-parametric method in like 2014. So that's kind of when I got started in machine learning. And once I saw that, I read ISL and ESL, and I was like, okay, yeah, this is probably what I should be doing. And then I went to work at a bunch of places where I did variations of those things for a long time. So it was probably the most beneficial course I ever took in my college career. And Greg is a really interesting guy. So it was really nice to spend some time learning from somebody who not just like knew about machine learning, but like successfully was practicing it, doing it. And like the tips and tricks I got from him were invaluable. I still use most of them today. So
ISL and ESL.
the introduction to statistical learning text and the elements of statistical learning. These are books that are old now, Hasty Tipsharani books, but like the stuff that's contained in elements of statistical learning is highly applicable to all the stuff that is being done today, even if it's not like one simple model doing it. But whether you're doing one simple logistic regression or an ensemble of 1,000 models, all different makes and makeups, those same core concepts really like dictate what works and what doesn't and why it should work. And I still this day have never worked my way fully through that second book.
Well,
And it's got so much depth to it. Like it's like the ISL book will show you how to do stuff. And the ESL book will be like, this is why you're doing what you're doing. And do that with a lot of math. And that's not necessarily something you even ever need to do. If you're cool with just saying, well, it works. But if you want to deeply understand these things, yeah, so just reading stuff like that. And,
you got links on a site.
yeah, I just shared them with Albert the other day. I have the PDFs. I can just, but if there's somebody I can email that will distribute them,
I'll do it.
Yeah, you guys go.
Actually, I have a copy of ESL on my computer. It's like, I think it's easy to find it on the internet.
Yeah, they're freely available on the internet too. I got those just from like Googling PDF, this book.
Yeah, that's my favorite thing to do when I'm looking up math books.
Yeah, I don't always need to go to zlib, but I think they deleted their Discord server.
Didn't the government shut that website down?
Huh?
Didn't the government shut the website down?
Yeah, so what they did was they changed it over from being a publicly available website to like a publicly available website that you couldn't download anything on. And the way you could download it is you would go to their Discord server and you would copy and paste the ID of the book that you wanted, and a bot in the Discord server would shoot you a private download link. So that's how they're getting around, but it just disappeared from my Discord like a week ago, so I don't even know if that's possible anymore. So hard to get books these days.
I mean,
I feel like it's
Amazon.
Sure.
Yeah, but
I remember not paying for like most of my like math textbooks when I was in undergrad.
Yeah. All my professors always found us PDF versions.
I paid
Yeah.
for all of them.
The copyright police are gonna get us before we
Okay.
even give this talk.
That's okay.
But yeah, I don't know. Yeah, so
yeah, like in your personal organization, what's the ratio of serious math heads to serious like tech heads?
well,
Kind of.
my personal organization is mostly me. For
Okay.
way research.
Yeah.
And the way it works is that we don't have any employees. We have contractors. So I work with a group of like 3 to 5 really talented AI engineers that I met through a course I took a couple months ago.
Okay.
And if they have work, they will toss me some work on their projects. And I'll work on their projects under my way research consulting firm. Or if I have a big project, I could be like, hey, yeah, I got like 3 sets of 20 hours for the next 2 weeks for whoever wants to take them, and I'll post them up there. And if then those guys are all pretty capable, so it's like I can just give them that and be like, okay, so this is what we need to do. Spend the time building and build as much as you can, and then I finish up whatever. So that seems to work pretty well. I do the same thing. I have a really good designer with one of my best friends, but he does a lot of the graphic stuff for us. I have a really solid, what do you even call him? A researcher, who does like app design. So like most of the work we do is like, this company has an idea that they want this thing, but most of the time they haven't really thought about why they want this thing, or what makes it work.
Yeah.
So I usually send in my friend in the meetings we first do with the company to go deep into what they really want. And that saves the company a lot of money, by determining, okay, we're not just gonna build a ton of stuff and just so we can have something. It's like, no, we're gonna build stuff that actually helps our business use case and matters. So, yeah, but I don't know. I think being a math head is great, but there's very little used for being a great math head other than like a pure research standpoint. Like if you can solve partial differential equations, that's sick. But I don't know.
No, it is.
Like I think it's super cool and I appreciate that skill.
No one's paid me to do that yet.
I don't see, I've never been paid to do it either.
Yeah.
And I think like, if you ever really want to know, like, you guys have Upwork?
What's that?
It's like a consulting website. You can just join as a consultant and there's tons of proposals and projects that people are actively looking to hire you for.
Okay.
And so I use this to source projects, but more importantly, I use this to source,
Go right on the board, anything.
yeah, it's just called UP work.
There is a marker there.
And there's like a bunch of companies on this website and they're looking to hire you at an incredibly deep discount rate. And so they'll pay you like $30 an hour to do something that most businesses would charge like $125 an hour for. So that's pretty much the whole idea of Upwork. But what's great is you can understand like what are people building right now? What do
Right.
people want? What do people like need? And what skills do I need to have to be able to service that? Because if any random person, you know, this like 5 to 10 person company that's posting this Upwork job because they don't have the resources to hire somebody full time, if they're looking for it, then these large corporations are definitely looking.
Got it. That makes sense.
So it's just a way to like think about like, okay, well, what am I seeing the most of? What skills should I really spend some time developing? And like most of you guys are what, like data science, analytics, kind of, so you have a lot of like Python, art skills with models and like,
I was a software developer for a long time.
Oh, okay.
So
yeah, so you picked up probably a lot more. What kind of software development work?
I did web development, so I would build apps internally for
So like a JavaScript developer, TypeScript
all of it. I
developer?
do JavaScript, I do
Java.
PHP, Java.
Okay, the whole,
Yeah.
you're the full stack of
Straight down to
web.
CSS,
Which
yeah.
is super helpful, I think, like, because it really gives you that window into programming, how other sides of things solve problems other than like numerical programming. And it's a really niche field. It's a very profitable field, but it's a really niche field. So less niche now, apparently. There's a room full of people I'm going to talk to. But it used to be really niche, and there weren't too many people doing it. What are you thinking, guys? 5:04? Should I wait another 5 minutes?
We got a pretty cool
You want
crowd
to do
now.
it good?
Yeah,
Okay.
I mean, once Syria rolls in, I feel like.
That's right. That's it.
Yeah.
Okay, guys. Well, if you didn't catch all that, and it's not necessary that you did, I'm Rick. I work for Way Research, which is the company I started to do AI problems. One of our specialties is time series forecasting. I also work for a bank, but it's a very boring job. I don't like to say that I work for a bank. So time series forecasting. This quote I think is probably the best quote I've ever found about time series forecasting. Right, like because it inherently gives you this image in your mind of like uncertainty and like how like when you're forecasting uncertainty, a very uncertain thing. And time series forecasting is probably the hardest discipline of any machine learning, AI, whatever discipline. It's not easy to do. And even if you're really good at it, you're still not that good at it. It's like the weather. They're pretty much go hand in hand. I had a guy once, I was working, I'll just share that story at another time. But yeah, it's very difficult. So here's kind of where I come from. Obviously, I work for Way Research. I cut my teeth on time series forecasting at Crable Capital Management, which is, I don't know, they have like $2 billion assets under management, like a medium-sized hedge fund in well, like as far as hedge funds go, that's a really small hedge fund, but they're headquartered in LA. They have an office in Milwaukee. I worked on predicting equity stuff. They were trying to get in equities. And I really cut my teeth on time series for forecasting working at Uniper. Uniper is the power trading arm of a European power trading power conglomerate called E.ON. E.ON is a massive company, and we traded mostly American power since we were in America. We also traded natural gas. I worked on the power side. So I kind of got better at doing a lot of time series stuff here. And then when I was unemployed, for like almost a couple of years, and not that long ago. I worked for this. I didn't work for them. I just participated in this competition, which I think is run by a Russian hedge fund. It's unclear what their status is, but they put these questions up. They'd be like, what do you think the price of the S&P 500 will be the end of next week? And they'll just have like a text box and you'd submit your answer. So I completed 408 forecasts. Well, the points don't matter, but I was 73% accurate on my forecast. And I've tried to figure out how they calculated that. It's a little unclear, but I was doing okay. The best guys were like 75. So and the difference was is they were submitting thousands of forecasts. They had automated it. And I just did these by hand in like Jupyter Notebook, and I did okay. So what is time series forecasting, right? You guys all came here tonight. You probably have some idea as to what time series forecasting is. This is a really grossly simplified definition of what time series forecasting is. But I think that's it's looking at past data and building a model that predicts future data. I think that's as deep as we need to go into what it is. So what's the history of it? Well, in ancient China, as early 800 BC, people were recording and trying to predict when sunspots would happen. This is a really historical, 3,000-year-old art of time series forecasting. And it's funny that the first Western notation or notice of somebody time series forecasting was also on sunspots. And those were separate things that happened, 2,000 years apart, but pretty cool that they were doing the same thing. Auto regression, which is one of the most seminal models of forecasting, was done in 1927. And ARIMA was created in the 70s by George Box and Gwynwell Jenkins. I think we could go back to like why this is important, and I'm sharing this with you later. But the quote at the bottom, this was told to me by that professor I mentioned years ago, and it is probably one of the most useful quotes I've come across as far as thinking about models. Cool. So now time series forecasting is often thought about as just something you do. But like time series forecasting should be thought about as a machine learning problem. So a lot of this talk is talking about how we set up a time series forecasting problem as a machine learning problem, not as just, oh, we're going to make a model and it's going to make a prediction. And that's great, because it's rarely that it will work. It's rarely that you even know if it's not working. So that's really all that is about. Okay, so like when you do machine learning, one of the first steps you do is feature engineering. So ideally, you want to create different kinds of features. Now, what's the problem with the time series and creating features? Okay, it's one series. So you have no X and a single Y, and you're trying to predict what happens next in that Y series. The next Y, right? So one of the things that often you have to do is kind of create something from nothing. You have this single series, a single column in a data set, and you have to use the time nature of this thing and create features. So these features could be lag features. So I'm going to look at, maybe I'll do some drawings. That might make more sense. So we have this feature set here, T0, T, N, and that's your series. And so then we're gonna shift it so that T0 starts here, Tn, and this is Y lag 1. Okay, you probably couldn't all see that. But essentially we're gonna take the series and just do a shift. And then we'll do this however many times we want to do it. So
can you repeat that? Because we couldn't see anything.
sorry, yeah.
Yeah.
So like we have this initial series, it's a series of length n, and we're gonna shift it one step. So now we have two series, they're pretty much the same data, except now the second series has been shifted down by 1. So it's aligned with the series T item T1, right? And so that's kind of like lagging a series. You wanna take it and set it back in time. Now, how you do that is important, because if you put it the wrong direction in time, then it doesn't make any sense. But you lag a feature, and then we'll create something like, ideally that's a rolling window statistic, like the mean over the last 20 periods or the standard deviation over the last year. And the nice thing about that is, besides the initial period that you need to fill up to calculate that statistic, once you have it, each time step has a new value for the mean over the past 20 periods or the standard deviation over the past year. So you get a whole series of those means and standard deviations that you can compare to the original values you're looking at. Other temporal features, just like what hour it was when this happened, what day of the week it was when it happened. And that doesn't sound like much, but it actually often can be incredibly useful when doing things like time series classification, all sorts of stuff. So that's a little sample of what you might do to create time series features from nothing. Okay, and then you're doing machine learning, right? So you create some features and you came up with a model, which you haven't talked about yet, but then we're going to figure out, okay, how are we going to validate this model? How are we going to test it out? So as you can see at the top, we have a little train and a little test, and then the test size stays the same throughout each of the folds, but the train set has gotten bigger. And that green area there is of itself a split set of a training and a validation. So there's actually 3 splits here. So we train and validate the model on this green section, and then we run it once on the test set to calculate a statistic. In this sense, you can train each split and then average the splits for a test error, or you could look at that test error from as a series itself and see if there's any trend in that series, because the series is happening with time moving down. So this is the earliest, this is the second earliest, and this is the latest. And then it would be interesting to say, and what ideally you'd want to see is, are these errors relatively constant or similar? It would be not the best if, like, the first training models were really good, and they got really bad. And then you'd be wondering, well, why did the model stop performing all of a sudden? Is it the model? It asks more questions than it answers. And I think ARIMA models improving consistently over time. That's a big one. When you do cross validation for time series. Okay, now I've probably just thrown a ton of information at you, and don't worry, the entire rest of this presentation will be exactly like that. And if you have questions about it, save them for the end. We will have a whole QA session. I just have to cover a lot of material really quick. Okay, so leakage. This is a big one. This is not something you normally see in machine learning because you're not working with time, right? So what's the problem with this? Code. Does anybody have any idea what's wrong with this code? You don't have to answer that, but if you do, you can say it. It's really sneaky. This is so sneaky, and this has fucked me up so many times. Excuse my language.
Right.
It's really gotten me good so many
Is
times.
this a coding problem or a math problem? Or is it both?
We gotta put it to a variable.
Yeah, that's the one thing I can think of.
They're fine, yeah.
Oh, no. I was just doing this for an example. I'll show you in the next slide. I'll show you what's wrong with it.
Well, what is X train and Y train like?
Yeah, that's, we can't see the whole code.
This is just a quick, like, little theory, right? So in this first line here, we're doing what we did in the first slide, but actually there's this hidden parameter called shuffle, which is always set to true. And if this was set to true and we're splitting our train test with shuffle set to true, does anybody see any issue with that?
Yeah, the time series gotta stay in order.
It's gotta stay in order, right?
Yeah.
So we're messing up the order of the time series, and earlier things are being put at later dates and later things, it's a mess. So you always, whenever you're splitting time series and using sklearn, shuffle equals false. This will save you days, potentially weeks. Do it.
That's hilarious.
So like leakage is the idea that time data that you couldn't have when you're building your model has snuck into your model training. essentially the future has become something you're using to predict the future, which is inherently a problem because if you're running your model on your test data, you're like, oh, wow, this is working so well. And then you use it in the real world and it's really problematic. So target leakage is the idea that we're using features that aren't available when we're going to have to make the prediction. So I came up with this really convoluted example where you're like working on an economic employment estimate. However, you're reading through the docs of the data and it says actually the data isn't from the day it says it is in the data set. It's from a day they released it 3 days later in the week, and then they back update the data set. So would you be able to use that feature?
No.
Okay, you not in its raw state. You would have to do something to it to say, well, now I know that that day is actually 3 days later. So I'd have to shift all my data, and then I couldn't use anything that was past the day I'm trying to forecast or train the model on, essentially. So no, you can't use it, but you could do something to it to make it still useful. Temporal leakage. I kind of came up with these names. There's not real clear descriptions of these things. So I'm not going to do a whole ton of Q&A with this one because there's a lot of code and not a ton of time for me to explain all of it, other than in this case, we created a scalar and then we fit the transform on all the data. The problem with that is all the data doesn't exist at all the times in the model. So if we give the scalar information about the future and it uses it to do stuff in the past, our model will be better because it is getting information through the scalar. It's leaking. And then call it a temporal leakage, call it whatever you want. I don't know. It's doing that stuff. And then in this case, we would fit two separate scalars, one with the training data, one with the testing data. And this will keep time lopped off where time happens for the training set and time happens for the test data. I don't even think I do this now that I'm looking at it again, because I think you would still have leakage. But scaling data is the most challenging thing for time series because it relies on an average, and that average happens over time. So you couldn't have I think that's my next example. So let's go to that. Yes, right. So like feature creation time. If you're just doing a standardized temperature, it's the temperature at time t minus the mean of the whole year temperature over the standard deviation of the temperature. But if that temperature happens, if that whole year is here, and we're only looking at temperature at time t, then all that future temperature data would influence the model. So what I'm trying to say is, with all these overly complex examples, is that this is time series forecasting is really hard because it's so easy to mess up. And then how do you know if you messed it up is probably what you're interested in. Is if your model looks like this after one training run.
One train.
Right, so you train it once and it's just like, it's crushing it. And you're sitting there and you're like, wow, I really figured it out. And then about a week later, you're, at the coffee shop thinking about, wow, that was a really good model I shipped out to that client. And in the back of your head, you start to think, wait, was there some leakage that created it to made it be so good? And in fact, there almost always is, because a time series forecasting model would rarely be very good. Okay, so yes, that's leakage. There's a bunch of other challenges for doing machine learning on time series data. Autocorrelation, where the values are sequentially correlated to each other. This can cause problems for most standard ML models. Time series forecasting models. Not as much the machine learning models, but still will cause issues. Concept drifts, where two features maybe predict well 2 years ago, but they have since stopped predicting well. So you have to kind of account for updating your model, not just the data in it, but maybe the composition of the model to keep its performance performing well over time. Distribution shift is pretty standard, which is referred to as non-stationarity, where the distribution isn't stationary over time. It goes up or down and does stuff. That's non-stationarity or distribution shift. And then sampling frequency would be, say, patterns that are at different time scales. So like if we're looking at a 1 minute, a data set that's putting out a value every minute, or we're looking at a data set that's putting out a value every week, there might be different patterns that happen on those different time scales, which could impact your models. Okay, so that was a whole lot. I hope you're all still somewhat with me, and that's good. We're gonna start talking about the models themselves now. This is, now that you know how they can all go so terribly wrong, now we can start talking about what they actually are and how to use them. So the first two naive methods I almost always use are random walk and random walk with historical sampling. What this does, if you're forecasting a time series, it tells you, okay, in a week, I know that the maximum will be a little bit less than 30 and the minimum will be a little greater than or less than -20, right? So it gives me these error bounds so that every other model and forecast I create from that point will have some kind of like a limiter on it, where it's like, I know that's reasonable if it's in the error bounds. I know it's unreasonable if it's outside the error bounds. Okay, so a random walk is essentially we start at the time point we want to start forecasting from. And then we take a step up or down. And then we repeat that for however many simulations you want to run. I think in this simulation on the screen, that's a 10,000 simulation, 10,000 paths are being generated. And yeah, so as you can see in this simulation, it's going up a little bit. Do you see that black line, which is the average of all the paths at that time step? It's going up slightly.
Yeah.
And I was like, why did I do that? It's because when I create my returns, or the difference, the next difference for that will be added to the series, the step, I set my mean to be, for the normal distribution it's being drawn from, to be slightly higher than 0, which gave it some positive movement. Some of those paths were returns were drawn more often from the positive side of the distribution, the negative side of the distribution. Albeit it was a very small amount, when you multiply it by 10,000 times, it has an effect. So there is a big effect on those distributions. That's the code that generated the data for that animation. Yeah. This is what I prefer, actually, to what I just showed you. It does the exact same thing almost, except it's a little bit more realistic, because it's bounding this. We're still starting with the current price, and then instead of randomly choosing a step in a direction, we actually look at all the steps that the series has taken in the past, and we pick randomly one of those. And then we pick another one and another one, however far out we want to forecast, and then repeat that process, say 10,000 times. And that, for me, has given slightly more realistic estimates. And this is always, you know, your first gut check. You're like, where could this thing possibly even go in the next 10 days? And then so every day you'll take a return and add it to the series and do that a bunch of times, and it gives you an error coding for yourself as you develop more complex models. Okay, great. We made it through the simple models. We're moving into two different things here. We're going to do the standard time series models. Now, these are models developed in the 60s and 70s. And we're going to do some deep learning models. And it feels like there's a pretty big gap there. But there's really probably a lot less of a gap than you think. Okay. So first of all, we talked about this a little bit before. But stationarity is one of the key, most statistical models have their hangups. And the hangups of the time series forecasting models is that the data needs to be stationary. So without getting over intellectualizing it, this top model or series, not stationary. This bottom series, stationary. And the only two things that make something stationary, not having a trend and a constant variance. And you could argue all day, does this series is constant variance? Because it kind of doesn't look like it is constant variance. But what you can determine for sure is you can run this thing called the AD Fuller test. And the AD Fuller test will give you a p-value for how stationary something is. And I think most of you know what to do with a p-value. And it's good to have that in your toolkit if you're not really sure. But most of the time, eyeballing it more than good. So just for giggles. Okay, so AR models, which are autoregressive models. These are the simplest form of time series forecasting. There's a formula there with some fancy notation. Don't get scared by it. The value at time t is just equal to some regression coefficient times the value at t minus 1 plus the regression coefficient times the value at t minus 2. And however many values you want to go back, it's literally just doing regression. So I thought you could think of an AR model as like your friend who bases tomorrow's mood on the mood for the past couple of days. So if they were sad for the past couple of days, they're going to be sad tomorrow. And great for data that has a lot of autocorrelation. And yeah, that's pretty much all I need to know about that. But we're going to go back and look at these little simulations I did because they really do show you kind of how the model is thinking. So we'll jump into an MA model real quick. So pretty much the same thing as the AR model, except we're building regression on the errors of the model and then adding that regression to the average value. So like, it's kind of hard to demonstrate, but let's compare the two little graphs, right? So as you can see, this little red line is the model prediction and the green line is the actual data. And you can see this is updating really quick and almost tracking exactly what the green data is doing with a lag to it. Because it can't be ahead of it because it's being calculated from the past. I believe this was order 5. I should know that. No, it's a 2. So it's only being calculated from the past 2 values. Order just means how many days back is the model looking at. So it's pretty jumpy, right? It goes right there. Now let's look at the MA model. And you see how it lags a lot more? And it is always trying to go right back to the mean. And it's hesitant to go as high or as low as this actual data is actually going, even though it's still kind of tracking it along pretty good. So it's that 2 skills, that autoregressive where we're gonna laggingly track exactly what the underlying data is doing, and that moving average model that we're kind of like going away from the mean as far as we need to make an accurate prediction. Great. So now we're going to do what is called an ARIMA. This is the most seminal model in time series forecasting that's been around since the 70s. It is an autoregressive plus an integrative term and a moving average model all rolled into one. Okay. This is like, this is it. This is all you really need to know. Now let's look at the graph of this. It's really kind of doing a combination of the 2 that we said before. You know, it's almost hitting, it's hovering around the actual new data, but it's not necessarily wildly moving to either side or lagging it that badly. It never works out as good as it does in theory, but yeah, so the integrated part, the I in the ARIMA is essentially a term that says how many times do we have to difference the series in order to make it stationary? So if the I was 1, then we'd subtract each of the values from themselves once. And if the value is like 2, we do that 2 times, and you can go crazy with that all you want. Rarely that you would ever see something more than 2. But hey, now you know what ARIMA is. And these are the ARIMA orders that I kind of just described, where we can get an autoregressive model by saying ARIMA 100. So that will only trigger the first autoregressive model. And then an ARIMA 001 would get just a moving average model. And if you just difference the data where the integrated term is the only one that has a 1 in it, that's a random walk. It doesn't always work out exactly like that, but it's most of the time a random walk if you do that. So ARIMA is just a very versatile modeling tool that has been used for a long time. So remember when I said we were going to create features earlier? We were going to lag stuff. We were going to create rolling averages and create, a wide feature space. That's when this comes in handy. And ARIMA with exogenous variables is when you get to add that X data to your Y data to predict the next Y value. It's pretty cool. It's pretty straightforward in most packages. But it allows you to start doing that kind of machine learning feature engineering in a time series setting. Now there's a new letter on the front, and it just stands for seasonal and ARIMA. And we add a seasonal component, which is saying like ice cream shells crush it in the summer, but aren't very good in the winter. So we want to account for that in our model when we're forecasting the time series of ice cream sales. So yes, now you know what SARIMA is, and SARIMAX, another letter again. It's just the seasonal ARIMA with that X feature space that we built. So now we're adding the X features in, and
Oh, I thought you were
Don't send it.
what's up, guys?
Boss
How
Baba.
you doing?
No.
Okay, cool. Oh, no, we kidding. So great. Deep learning. You made it. You made it. Just like everybody, pat yourselves on the back. You made it through standard time series forecasting models. You're somewhat closer to the present day. Deep learning models suffer from a lot less constraint. There's a lot less assumptions that have to be met to make them useful. But they also have a lot of drawbacks. They're non-interpretable. They have tons of hyperparameters, and they're computationally intensive. And for you, the programmer, setting these things up, they are very time-consuming. Those models I just showed you, you can get running on your computer in 20 minutes if your data is clean. And, obviously a lot of things go into that. These models, you're not going to get running on your computer in 20 minutes. So with that, doing time series with gradients is kind of hard because essentially it's the forward pass that produces the value and then the backwards pass that adjusts the weights. But if the backward pass is really long, the weights get smaller and smaller and smaller until they disappear, and then the model has become essentially useless. And so how did they solve that? They solved that with an LSTM. And all you really need to know about an LSTM is that it stands for long-term, short-term memory, long, short-term memory. And the way it works is it has this kind of built-in logic gate that knows when to remember things and when to forget things. And I'm not going to go any more into it than that because I don't even know if I know more than that. I use them pretty regularly, and I don't think you necessarily have to know more than that to know whether they're producing good output or not. A gated recurrent unit is pretty much the same thing, except for the fact that it uses less memory, but they both solve the vanishing gradient problem, and they both are pretty much the same, but nobody uses GRUs, so I don't know what. And then I bet you all have heard of this one. I don't even know if I need to tell y'all about this too much, but I think generally speaking, they're useful. They're just really hard to do. Yeah. And then this is the most promising one I've seen. It's really new. It's like in the last year. And it's supposed to be pretty good. And it has a variant called TimeMamba that is just for time series data. So that's supposed to be really good. It's done well across a bunch of different things, but it's supposed to be good for time series too. Okay, great. We did the models, we did the deep learning, and now how do you do any of this stuff? Like take that model from, oh, I know about it, to I can run it on some data I have. Statsmodels is mainly how you do all the earlier models I talked about, the ARIMA models through the SARIMAX models. Really well implemented, really well documented. This is called a seasonal decomposition. And you'll see this a lot in time series, and it's pretty helpful. Here's the original series. And here's the trend of that series, where it averagely is going. And then this is a 24, I think this is an hourly data set. So this is a 24-hour seasonality. So you can see it goes up and down quite a bit in 24 hours. And then this 168 would be the weekly seasonality. There's 168 hours in a week, potentially. And then, so that goes up and down, but it has more of this like Dilbert pattern to it. Yep. And then this is the residuals. So you'd want that if you're building a model to be kind of consistent, just like in regression. Okay. Sktime is awesome. It's pretty much just scikit-learn for time series. That's kind of all you have to know about it. There's a little example, like they just build a forecaster, arrange some data into the future, and then fit on the Y data, which is the airline data, and then add that future data as FH, and then they just predict it and plot it, and there's your time series forecast. Whether that's a good time series forecast is up for debate. It looks pretty good to me. Does seem to kind of taper off a little bit, but to be able to do that in 3 lines of code is always nice. But if you're going to just look for something to give you a baseline, you're going to want to use Profit. Facebook developed Profit a couple of years ago. I've used Profit for consulting for developing models. It's really pretty straightforward. You just create the model, you fit the model on this data frame. That DSY is the input format. So you put your timestamp in the DS, and your Y value is the time series value, and then you feed that into the fit function. Then you do this crazy thing, which is you make the future data frame, which is the empty data frame that is lined up with your time series. And then you create a forecast, which is predicting the model that you fit on the future data frame. And then it gives you these, timestamp, the predicted value, the lower bound and upper bound of that prediction, which is really nice. And that's all it takes out of the box to get something going. And it's actually pretty good because it's a Bayesian state space model, and I don't have to. It's like a very fancy version of what we were doing earlier. And it just works out of the box. And you get this plot that shows you the black dots are the data and the blue is the prediction confidence interval. It's really good. Like you get a baseline with a random walk. You get a much better baseline with this. These models can be wrong. So don't like think that this is just like predicting the future and perfectly working. It gives you something better, but it's really hard to cross-validate this profit model because it takes a long time to fit the Bayesian state space model. So in a cross-validation setting, you're just really like you would sit there all night just to get like a tenfold cross-validation done on a reasonable size series. So great for testing, not great for implementing. Darts and Orbit, two other great libraries. Orbit is Uber. Pretty much the same thing as Profit, but by Uber. I haven't played around with it too much, so I can't really vouch for it. But yep. And then if you want to do TimeMamba, here's the library you can use. It's a research paper. So if you are feeling like hating yourself, you can try and implement TimeMamba from scratch. I haven't really felt like that recently, so I haven't implemented it, but it's always a possibility. Okay, this is my favorite part of this talk. What is wrong with time series forecasting? There's a lot. The future isn't always predictable from past data, and I think we all know that. But like specifically in time series forecasting, black swan events, crazy stuff that happens that there wasn't any way we could have thought about. Having to assume stationarity, which isn't that big of a deal, but it's annoying. I guess the butterfly effect, although that's not really my biggest go-to. This one, though, most models assume Gaussian distributions, but the real world data often has fat tails. This is super true. Almost all of our forecasting libraries are built on like a Gaussian curve. And the problem with that is if we're sampling from something that's Gaussian, but it's actually like 10% more likely we'll see something from the tails of that Gaussian. The events that we really care about modeling aren't showing up in our models. And then we're all like, yeah, it's all good. And then something terribly wrong happens. And we're like, it was a black swan. But nobody thinks that their model might have been wrong. So yeah, deep learning models are a pain in the butt. I do a lot of deep learning, but in time series setting, it's a pain in the butt. And ARIMA, or more importantly, SARIMAX, often performs 95% as well as the deep learning model with no work. And it says ask Mommer. My friend Mommer Almari, he hangs out at Cafe Aroma a lot. If you ever see a sprightly Arab man walking around, he's a great resource on this stuff because he's a machine learning engineer at CBS. And he deals with a ton. I really wish you could have come down. He deals with a ton of time series data at CBS. And they're cooking temporal fusion transformers. They have a whole team of data scientists, AI engineers working on it. And it performs 3% better than the SARIMAX tune model. And they've been working on that model for months. So the state of the art is barely doing better than what George Box came up with in 1970. For what that's worth. So this book really changed my viewpoint on time series forecasting. Benoit Mandelbrot came up with fractals. The idea of, I don't know if you've ever seen a fractal. I think there's one right here. That's a fractal. It's just a self-repeating pattern. It's infinitely dense. So there's infinitely many patterns. The more you zoom into that object. So he came up, I just read this like 6 months ago, maybe. And he came up with the idea that fractal patterns exist in the markets. And every time you see the word markets listed right there, you can think of all time series that are naturally occurring. So markets aren't Gaussian. We just talked about that. Markets have a memory. One of the things a lot of these models assume is that the time series doesn't remember what the time series did. But actually, the time series do have long-term memory and volatility clusters. So when volatility happens, it's more likely to happen. When volatility doesn't happen, it's less likely to happen. So how would you fix time series? The ARIMA killer, this model that keeps crushing our best deep learning models, obviously got to make it non-Gaussian. I think searching for fractal patterns inside of the time series and using those to forecast makes a lot of sense. Simulations from distributions that are relevant, not just distributions that are the whole time series, and then account for that volatility clustering and series time dilation. And series time dilation is just a fancy word I'm using to say a lot of stuff happens at once and nothing happens for a long time. Yeah, that's a detail. We don't need to get too much into the whole thing, but so I came up with this model called fracTime, and it is essentially everything that I just listed on this page. There's a lot of fancy terminology and what have you here, but it's really just about like, okay, we need to fix time series forecasting a little bit. And there's a really good evidence that this guy came up with a potential solution. So this is just an implementation of that. And this is all I'll leave you with. There are a lot of really shiny models out there, but often the simplest ones perform just as good as the fancy ones, maybe to a couple of percentages of accuracy. And yep, thank you.
I'm interested in what you built, the fracTime.
Yeah.
Can you talk a little more about that?
Yeah, so like, you know how I talked about that random walk where we're sampling from the returns? So essentially it's really similar to that, except we're really deciding based upon what is happening. You know what a hidden Markov model is?
We learned Markov models in what, 616?
616, yeah. Okay.
Yeah. So it essentially creates a Markov model of all of the distributions that the time series has exhibited. And then it figures out what is likely to transition from the state it's currently in, and you're sampling from that current state, but is it going to switch over to this new state where it'll create a slightly different distribution of sampling? And tracking that over time. So you fit that, and then you start to do some simulation from that HMM of distributions, and that creates these new look forward paths. And you're going back into the data and you're saying, okay, are there any fractal patterns, meaning a pattern that occurs at a bunch of different time scales that exists? And then we're going to look at all those new simulations we created and say, do any of those new simulations look like the fractal patterns we mined out of it? And that way you have like a better data generating mechanism. And then we can not just only say like, oh, there's this one pattern direction that we'll take. We could put a probability of how likely each of the future paths is. And then we could say, well, given a couple different scenarios, these potential future paths are most likely.
You can't, that's nuts.
What?
That's crazy. That's awesome, man.
Yeah. So, yeah, and then I drive a lot and I listen to books on tape. So I kind of just came up with that one when I was listening to that book I showed you. Really good stuff. Was really feeling that one. So I came up with this thing. It kind of works. It needs a lot of testing, just like any software project. And time I don't have a ton of. So yeah, but if anybody here is ever interested in checking it out, it's just a GitHub repo.
When you said the time series like model has long-term memory, what do you mean by that? Like
Things that
exactly, like-
things that have happened in the past often happen again
Yeah, but how? Like, oh, okay. In time. You mean.
in the time series. So like
Okay.
say like there was like so say like there was like this big build up and a crash, and then all we've done is build up for a long time. What's gonna happen?
Crash.
It's gonna crash. And there's no reason why it does that. It just does it. It doesn't matter. And if it didn't constantly do that, then we can say, oh, this is just random stuff. It doesn't matter, but does.
But does that mean like it will give us like a wrong prediction?
You can't rely solely just saying that, oh, that thing happened in the past, so it's likely to happen again, because A, you don't know when,
Yeah.
and B, that's not necessarily in nature, but if you allow your model to learn from the past events, then you can assign probabilities to the fact that it might happen again, and you can start to really think about them when they start to become more and more probable.
Thank you.
Of course.
Can you explain about the trading time warping technique?
Yeah, that's just a fancy, that's like, yeah, okay, so what's the difference between machine learning and AI?
Um,
It's kind of a trick question. So AI was actually developed first. The name AI was done by computer scientists in 1952, and machine learning was actually created by statisticians in 1956. And AI caught on because it's infinitely more catchy, and computer scientists are infinitely better at naming things. But that's what I'm doing right there. Is I said volatility, clustering, and time series dilation. You can think about like the trading. You can think about like the time series having a clock. If it's not, each point has a value. Like say like if there's a lot of moves going on at once, the clock is moving faster. If there's not that many moves happening, the clock is moving slower.
okay.
It's like a harmonics, right?
Yeah, pretty much. It makes my project sound cooler than saying volatility clusters.
For non-Gaussian models, do you have any, like, have you run into any that work better than Gaussian or?
I mean, I just haven't tested it that much, honestly. It's theoretically should work better, right? Because you're saying the likelihood of something crazy happening is much higher. So we're just gonna account for that and then build our model on that. One of the things, I don't know, I work for a bank, they're trying to get me into this risk role. And like most of the stuff is just like Bayesian insurance problems. I don't know. I don't really want to understand how counterparty risk is managed at Citibank because I don't understand it and I would just butcher it. So, but yeah, essentially like it could have a lot of impacts if like we just slightly gave more and like all it'll really do is like take an error bar from here and put it to here.
Yeah.
But that could be a big difference if that's billions of dollars on the line. The accounting would be better. But I'm not like, I don't know, I don't want to go on some like tirade about time series models are wrong, because I don't really care if Citibank has a massive loss. They're a mass multinational bank. How's that affect my life? I think personally, it would be cooler if we could have a model that performs slightly better on time series without a ton of deep learning work that has to be done, especially just to gain an extra couple percentage points of accuracy. That's really that's the basis of the project. That's why I started it, and I'm working on that.
You said you'd like to avoid deep learning if.
Yeah, this model is not deep learning.
Right.
It's not, it's actually just pretty simple. Barely ML stuff. It's mostly just sampling and pattern recognition. I think you could probably make the pattern recognition a lot better with deep learning, but I'm not gonna take it there unless I have to.
Why might you want to avoid deep learning?
Just because like it lowers the barrier of entry. It also stops from like I just love things that work on simulation because they're fast. You can simulate millions of NumPy simulations in like 50 microseconds. Like if you could do something almost on simulation, then you could do it fast, you could do it on any server, anywhere, at any time. Deep learning has a lot of like build constraints. It needs GPUs, it needs dedicated, and then you can get all that. It's annoying.
Also something to be said about like the deep learning, isn't it like less explainable? The outputs that you get?
Yeah, and I don't necessarily know that this would be explainable, but I think it would be more explainable than just like a raw deep learning. Yeah, you can't look at a deep learning model and be like, oh, that's why it does what it does. Yeah, I think explainability used to be a thing that we all just kind of gave up on.
Can you talk about your experience tuning like SARIMA models, ARIMA models? Like, are you grid searching? Are you?
You could do pretty much any standard. I mean, like if you have some intuition on what might make sense, but like who?
Yeah, exactly.
How many times different a series? So just standard machine learning techniques.
Okay.
Grid search. I prefer random search to grid search.
Okay.
Generally. But yeah, those are all just hyperparameters. I didn't really say that, but I should have.
What kind of work do you do with time series analysis of your company, Wave Research?
Nothing yet, but hopefully we'll get a project at some point.
Awesome.
How did the company start for the most part? Were you like on Upwork and it came from that, or was it from talking with people you networked with?
It was actually a startup to invest in other people's trading strategies. But I took that to Citibank and they were like, you absolutely cannot do that. And I was like, well, can I do this instead? And they were like, sure. Yeah.
Do you have any models you're running, doing like personal trading or no? Like your own?
I can't really do that. I can do crypto. I'm allowed to do crypto for some reason. I don't know why that's any better.
Oh, what do you mean allowed to? What do you mean?
Like I can legally trade crypto as a person who works for a bank,
Oh, okay.
but I can't legally, like I have to get any trade I do for a stock. I have to get that cleared by reg.
Oh, wow.
Regulatory.
Oh, it's regulatory. At least like
There's this guy Greg. He was in regulatory.
That's interesting. I assumed it would just be like Citibank stock, right? But no, that makes sense.
No,
Yeah,
anything.
you can't touch anything.
Well, because I don't handle money, but we should, I have the ability to handle money.
Yeah.
Take like 2 weeks off every year to make sure that I'm not money laundering and. Yeah, it's cool.
So you're not interested in trading crypto though, like in your spare time, like using your skills to do that?
I know my buddy my buddy at CVS, but they don't have those same restrictions at CVS. I should be working at CVS. No, he's been building agents, RL agents. And I built him a library for RL agents for trading, but
There are RL agents?
reinforcement learning agents. They're like, instead of like standard machine learning, they have a policy and the policy gets updated based upon the environment that it's in. So you have the agent with the policy and the environment and they interact. Yeah.
You mentioned before when you were going to school that you took a break during that year. How did you gear yourself for the job market to be able to take that break and still come back?
If I'm being honest with you, I was working for this subcontracting. I was subcontracting through this company called WNY Partners on Google projects. So like I would show up as like Rick at google.com or whatever and work on these projects. I was working so hard that I had a severe psychotic break and didn't work for 4 years. So like I've only recently come back into the job market, but I was doing like 100-hour weeks, waking up every day. I was waking up every day at like 4 a.m. so I could get to the office by 4:30 so I could meet with the offshore team, and it was just a mess. But I learned a lot in those 4 years. I just did I didn't work anywhere. I just did odd jobs around Buffalo and like I did stuff. I wasn't like completely out of it. I just it was a learning experience. And then that's when I went back to school because I couldn't get a job.
Okay.
But I think like if you're looking to get into the job market, the thing I need to tell you guys, as somebody who's also applying for a job right now, do not apply on company job portals. Do not do that. It's a waste of time because they are getting dumped on by AI resumes and AI people. You need to go on LinkedIn and you need to figure out, okay, who in this company can introduce me to the hiring manager for that role? Do that. That's way better. I got because I work with I'm in this group of people that did this class and we all just are trying to get AI engineering jobs. Those guys, not one of them has gotten a job through applying through a job portal. It's all been through posting good content on LinkedIn, making yourself a subject matter expertise. It's all been through networking through your existing network and saying, oh, that company is interesting. And my friend Tom works there. So I need to reach out to Tom to see if he can maybe introduce me to somebody who could introduce me to somebody who's hiring for that role. So I think it's like use the network stuff, build your network, work on that. And yeah, I don't know. I don't even know if it's good advice because I haven't gotten any.
No, that's great advice. I'm not gonna lie, that's great advice. And how would you say, since you've been in the burnout situation, 100 hours is really crazy. For us, like getting into the job market and probably gonna get some crazy hours or crazy workload, how do you think we should balance out our work-life balance? And how do you feel like we can also get back to ourselves for the work?
How do you get to work?
I don't know, I was just saying, let's say 6.
6 a.m.?
Yeah, let's say 6.
You're getting to work at 6 a.m.?
No, right now I get to work at 8:30.
Okay, yeah, you get to work at 8:30. What time do you leave?
I like 5.
Yeah, just do that. Seriously, it seems overly simple, but if your manager is like, oh, this needs to get done tomorrow or else the world's gonna blow up, and just don't. Your time is when work ends. That's your time. You sold them 40 hours a week, 52 weeks a year. They don't get more than that. If they want more than that, they should be paying you more for it. And in a salary role, you will be actually getting less money because you're working more hours. And so somebody's like, well, I noticed that you haven't been, putting in as much time as Jen.
But has Jen been working over her hours or she been working the same hours?
I don't know what Jen's been doing, but she's been working a lot more than you, I guess. And you have to be willing to say oh, I can do that. and I'm comfortable, putting myself in a higher position, or you just say, that's fine. Nobody asked her to do that.
Yeah, that's so good.
It all averages out, right?
I mean, I work a lot still because I work for two things.
Well, if Jen's staying late, then can I leave early then?
Increase contingency, not go up.
But yeah, if it averages out. Okay, so more career advice stuff. You're involved in a couple of groups where we meet up. We were at what's that place called, like Bottle Cap and Bites earlier this week. Do you want to plug some of those groups so people here know where to network?
Yeah, I think like if you're interested in like machine learning AI stuff, we run this group WNY AI, and WNYAI.org. If you go onto that website and you throw your email in there, you'll get a weekly Monday email with all the AI events happening in Western New York. So I aggregate those. I'm the one sending the email. And I think that's like what we're building there is less like we're putting on events, and we had our coffee on Monday, Wednesday, something.
I don't know.
I don't. It was Wednesday. It was Wednesday. I never know what day of the week it is. It's Friday today, everybody. But no, so there's like another group that puts out it's called Buffalo Way. It's called
Bio or something.
Buffalo. It's Buffalo with AI thrown into the word. And it's done by
paper. It's hard to say.
It's done by my friend John Spitz, and he's like a real estate guy, and that's more like his group is more like business guys who are vibe coding their way into the AI space. I'm not saying that like derogatorily, because I really do think that people just picking up AI and playing with it is a good thing, and getting AI literate and like trying to learn how to build things. And then all of a sudden, like this real estate guy who's never touched a computer in his life is like asking me about Postgres. And it's like, that's cool. I appreciate that. But so his group is more like builders. WNYI, like the group that Sam Marazzo has put together is more like practitioners and researchers. So that's should be a little more heavy, but it's all skewing towards just like, oh, what weird app did you build? And I love that because I built 18 apps in the past 6 months, and it's so much fun. I literally I can't get enough of it.
What type of apps?
Oh,
Web apps or like?
I built a spiritual 90s theme plant tracker for your sacred garden. I built a oh, now I'm gonna blank on all my apps. I'm building this thing right now with my group. Like in the group I'm in, I have a project manager, and he just keeps me on track. And the idea is it's called Vision Quest, and you take like, say like, oh, I want to build a supply chain for bonsai globally. And you enter that prompt, and then it'll come up with a fleshed out, very intensive idea generation note that like is all that there's like some examples on my LinkedIn, but essentially like it uses AI to really dig into an idea that you have and build it into like a document that is every potential aspect of that idea. And then if you want from there, you can take that. If it's like a tech project, you could take that document and use that to generate a project with milestones and tasks. And then it'll organize work sessions for you so that you just set your work hours. Those milestones and tasks will be split up into sessions, and then it just throws them in your Google Calendar and say like, in this hour, you're working on this, this, and this. Next hour, you're working on this. And it keeps you on track over time, because I have a hard time staying on track.
Your own like project manager.
Yeah, it's just an automated project manager is all it is.
Speaking of LinkedIn, I'm sure everyone here would like to connect with you if they haven't already.
Yeah, sure, guys. And it's just Rick Galbo. I guess I didn't even put my full name on this presentation. Long presentation, holy shit. I didn't even put my name on this. That's funny. It's GALB as in boy. Oh.
You write on the book, please?
Yeah, absolutely.
Right there on the screen.
You got some really good ideas.
Yeah,
That's
nice.
top.
Where?
Look, it's right there, Rick Galbo's
Yeah.
green.
Yeah, I couldn't see that.
There we go.
That's me.
Alright, so what's next for Way Research?
Alright, I'm trying to close like 3 projects right now and I'm trying to leave my city banking job. Probably like a 6-month time around on all of those things.
It's awesome. Well,
Yeah, thanks for coming, guys. This is really cool.
yeah.
What's the next WNY AI event?
We won't have another coffee until next month.
Okay.
But
Movements.
I know there's a buffet IO, whatever.
Yeah, that's-
Thing next week.
that's next week. I'll be going to that.
Okay.
I try and go to all the events because I think it's just good to get involved.
Yes.
Okay.
Yeah,
I was planning on going.
We might have another talk.
I apologize. No, you're gonna apologize.
I could probably get other people to come talk here. How frequently are you doing the talks here?
Like every week, pretty much every Friday.
If you wanna pull up and bring some friends that.
Well, I think, no, that's good because I'm trying to develop a talk series for my Western New York AI, whatever. You guys are already